someone that will qualify the rock star of learning science, someone who is Chief Learning Officer at Kaplan and who is going to join the Chen Zuckerberg Foundation very soon. So please join me to welcome Bror Saxberg.
Everybody, close your eyes. Hello, hello. It is great to be here and chatting a little bit about learning engineering and the application of learning science at scale. This is a topic that keeps getting bounced around a little bit, but it's not been directly hit head on that I've been seeing in sessions, which is how do you actually apply learning science to get things to actually work better with technology or without? So that's what I want to talk about. And the basic idea is to really put the evidence about how learning works to work. So start from how learning actually works, as opposed to how you wish it worked, or as opposed to other people's mythologies about it, and then use the technology to implement good solutions. So take just a second for now. Think about your worst ever university professor. Just hold that thought in your mind, all right? It used to be that that person could only damage a few thousand students per year. Now, thanks to the glories of education technology, that person can damage the interests and loves of millions of students around the globe 24/7, right? You know, fabulous YouTube videos of a person who's just soul destroying, right? Win for technology, yes? No, it's not a win for technology at all. So technology doesn't care. It will take a good learning solution or a bad learning solution and make it more affordable, more reliable, more available, more data-rich, more personalized. So the trick is we have to find good learning solutions and then use technology to drive those, and then use evidence that comes from the technologies, and as we build and adapt and iterate, use that evidence to actually make progress and then ultimately change our practices at scale. So I would argue this is what learning engineering is about. That's what learning engineering is about. And that's what we need to get our whole ecosystem to start to do, whether it's venture capitalists asking for demonstrations and pilots and good evidence that something has made the difference that was promised, whether it's buyers and colleges and high schools and regulators insisting on, show me some evidence that this thing actually works, and then the providers of various elements of the ecosystem to make this all work. So this is learning engineering. So in order to do this at scale, and Kaplan, where I am now, is at scale. We have 1.5 million students a year, all kinds of different learning environments spread around the globe. How do you make such a change across 22,000 employees? So, well, let's see if we can make this work here. Give me a second. Yes, so the first thing will be exposure. We got to expose people to what's possible from applying learning science at scale. Then we educate to show this is how it can be done, let's get you through that. Even doing that, you now have people who know what to do. Will they actually do it? Well, that's actually going to require some effort. And we'll talk a bit about some of the general management work that we've been doing at Kaplan. And then finally, once you actually get things up and running, you need to evaluate what you're doing. You got to close the loop, make this into an iterative development cycle. So this is what we're going to talk about. So let's start with exposure first. So here, you want to actually show the science. This is new information for most instructional designers and certainly for faculty and teachers. So show it to them and then show some new processes and give some examples. So I'm going to attempt to do a 90-second master's degree in modern cognitive science. Ready for this? This will be exciting, okay? So the modern cognitive science view of how learning and expertise work says we have two pieces to the information processing in our mind fed by audio and visual channels. One piece is working memory. That's the part that has our verbal selves in it. It's flexible, it's slow, it loses stuff, but it is the part of our minds that can do the most work, the most hard work. If we only had that, we wouldn't be very effective at most of our lives. That working memory is supported by long-term memory. Long-term memory, it lasts a long time. It's also very fast. It's non-conscious, which is irritating because it's hard to know what's already gotten into long-term memory because the words aren't there anymore. It can run in parallel. If trained properly, it's actually quite accurate. So the trick is you want to get stuff into long-term memory that belongs there so that you unload working memory. So quick question here. Who here drives a car? Raise your hand if you drive a car. Okay, I tried this in Singapore, it was a disaster. Okay, good. So think about this. Raise your hand if this has ever happened to you. You set out for place A, and then you start thinking about, your research or your EdTech company, your venture capital, your family, and you look up and you're in place B instead. Raise your hand if that's ever happened to you. Yeah, see, look around, you're not crazy, not for that reason, okay, right? So, in fact, we just laugh and move on, but who drove you to the wrong place? Who was in charge of a ton of metal going, 20, 50, 100 kilometers an hour? Because it wasn't you. And that's not like digesting a bagel, right? It's a learned thing. We didn't evolve to drive a car. So our learning processes give us the ability to have these complex cognitive things happening automatically in the sub-basement of our minds, freeing up working memory to other things. Now, there's plenty of skills that draw on long-term memory, but also have to be using working memory. So, for example, writing a persuasive essay always draws on working memory, but is supported by lots of things in long-term memory. The more things you put in long-term memory, the more effective that writing is going to end up being. Okay, second piece of research here is about motivation and how does motivation actually work. So what we're after, sorry, I'm gonna have to click through this real quick and see if I can get this to show. Give me 1 second. What we're looking for is how do we get people to start, persist, and put in mental effort? What does the research say about this? We had a very good researcher, Richard Clark, dig into a whole bunch of domains of research to figure out what does it look like? What are the things that go wrong? And what he came back with was a model of 4 things that go wrong with motivation, meaning what gets in the way of starting, persisting, and putting in mental effort. One thing that gets in the way is just simply valuing what you're doing or how you're doing it. If you're a dancer in an algebra class, you're probably thinking about Swan Lake, not models of, of complex variables or something. So you got to figure out how to draw the link to the person, how to make it interesting to them. You got to handle that value issue for some learners. A second thing that goes wrong is self-efficacy. Another dancer, the same algebra class, I'm no good at math. Well, you can't come bustling up to me and talk to me all about how important it is for my future, because that's not my problem. You're just making me miserable, right? I wish I could do it. I can't do it. So the problem solving around this motivation problem is to say, you can do math. Let's back it up. Yes, you can do math. Even horses and cockroaches can do math. Yeah, never introduce me to your students. Never introduce me to your students. But I mean, you can't, it's not true that you can't do math, okay? That's not true. So you got to back them up and solve it. Attribution errors are similar. Instead of, I can't do it, I blame something in my environment. I think it's important, I could do it, but I can't understand this textbook. My TA hates me. I don't have a space to study. Or very popular among many professionals, I don't have time. And that's why I don't start, persist, or put in mental effort, right? The last one is mood, negative emotional states. If you are angry, scared, depressed, it's tough to start, persist, and put in mental effort. And that's different from all those other ones, right? So all these things, they have their own things that go wrong and own treatments for each of these things, right? So this is all part of the learning science, the underpinnings of what should be going into learning environments, and a lot of it is not. So if you do it right, you should be able to really explain a kind of an engineering process, which is what we've been using at Kaplan, where you start by understanding expertise. A very detailed way of doing it is cognitive task analysis, but it can be other things too. Once you know what your learning outcomes are for the professionals you're trying to duplicate, you then use evidence-based methods. So you try to find methods that have support for the kind of outcome you're after, especially for the hardest things. You also need very high-quality measures. And this is a problem with a lot of ed tech, that the measures that we're trying to use for AI and training neural networks or adaptive learning or trying to build inference models, complex latent trait class analysis models, if the learning assessments are garbage, all of that complex analysis is going to be a very rich analysis of garbage. And you're not going to get where you need to go. So you need to have some rich evidence that your assessments are valid and reliable probes. And then finally, if you're working, you can actually start testing things quickly. And we do some of this at Kaplan, where we've done 150 randomized controlled trials because we have 30,000 students in a virtual university, Kaplan University. Some of those courses will have 1,000 students starting every month. So you can just begin to do controlled trials across those things and just get going. And we should. We should begin to move at pace when we have environments like that. Okay, exposure, maybe some examples of what that looks like. Now, how do you educate? Well, this is actually hard. The first thing is, you got to make sure that instructional designers and faculty begin to embrace this idea of backward design. Who here knows about backward design? That's a thing that a lot of people know, where you want to start by saying, what are the, what are the learning outcomes? And then what is the evidence we're going to gather against those learning outcomes? That's the assessment. And then what is the practice and feedback we need to get the right evidence, and on down, right? That's how you design it, because that way you can then very gracefully prevent useless information from coming into the course, because you can just point to the outcomes and say, yes, Mr. Professor of Accounting, your favorite intro lecture on the history of debits and credits, the medieval monk and how he did the tea thing and all that one just doesn't seem to fit any of our outcomes for our accounting course, right? You have a graceful way of pushing things off that are not contributing to what students need to do. And then, of course, you deliver in the other direction. You start with your overviews and information, et cetera, et cetera. So you want to make design processes like this, where they are backwards design and then go forward. And what we had to do at Kaplan was to actually acknowledge that, in fact, our designers are human beings. If you need references on that, I got them. It turns out faculty and instructional designers have minds, which means everything that we know about learning that we're applying to our students, we have to apply to our instructional designers too, because we're going to change their practice dramatically at scale. That means major league training courses. We have online materials followed up by an actual couple of days of workshop where small teams get together and start to try to build something. They actually do a team project over several months to actually build out modules. They get feedback from trained instructional designers who know how to do evidence-based work. You have to pay respect to how difficult it is to change people's minds, including the professionals who are supposed to change people's minds. So this is a big deal, and it's non-trivial to do, because people are often trapped into their own ways of doing things already. So the third piece of this is then, you've trained people, you got this all working, you're beginning to make progress, but how do you finish the job, right? Because if you're going to do this at scale, this can't be about volunteering. This needs to be about getting it done. So it gets tricky. How do you make it be a wider phenomenon? Well, one thing you can do, and we've done at Kaplan, is you create internal communities. We have a thing called the Learning Architect Community that pulls together all the folks who design learning, design assessments, design IT that's tied to that, analyze assessment results to look for learning. All of those folks we consider as part of the Learning Architect community, and so they talk to each other, we bring in outside speakers, that's a community piece. But we also had an interesting conversation, and it was our chief financial officer, amazingly enough, who had this brilliant insight. He said, if we're going to make this learning engineering a deep part of how Kaplan runs, we're going to have to get the general managers to understand more about learning. So think about what a general manager does. They know a little bit about marketing, a little bit about IT, a little bit about operations, and they know enough that they can explain why did they prioritize the resources and money and labor that they're putting in. They can say, here's why I did these 3 things in marketing, and here's why I stopped here. And they're not wrong, they're not dumb. They rely on their own marketing people, but they can describe that. In learning, typically general managers know almost nothing. So they end up managing it by things like head count. I'm adding 2 people to the learning team. It's like, adding bodies, that's how you manage a morgue. I mean, that's not how you manage a strategic investment. I mean, what is that, right? So you got to say something more than I'm adding 2 bodies. What is it for, right? And so that requires real effort. And our CFO had the idea that, yeah, we do these general management meetings, right, where you cover the business, you walk through all the elements of the business, every quarter, business review meetings. He said, we can't add learning to it because it'll be new, it'll always be at the end. Look at the time. We don't have time for learning this time, but surely next time we'll bring it up. And he said, let's add 2 more meetings to the quarterly review calendar. So now we have 6 meetings, of which 2 are only general managers talking about their learning strategies, their learning priorities, their learning trade-offs, their learning challenges, with the global CEO and me and the CFO. And no general manager wants to know less about the learning in their business than the global CEO does. That, you want the silverback to be proud of you. We're all primates here, right? So the big silverback, you do not want him to know more about your problems than you do. So what we did is to set up a series of meetings beginning last year where we first got some general work done on what are your learning outcomes on your largest, most important courses, the assessments. What work are you doing to demonstrate that these are actually valid and reliable probes of your work? And then the instructional design. How are you using evidence-based methods to work on that? We then followed that up just in April with a meetings that talked about, so now you have all this good stuff. Tell us, what is your plan for pilots? Well-designed, ideally randomized controlled trials, but if not, that's okay. But describe what pilots you're doing and why, what measures are you using, and so forth. And then finally, what's coming next in September will be something about, now let's look at your delivery. How are you using data about all your delivery to then inform what pilots you do and what changes you make to these here? So it's the general managers who have to have that conversation, right? They can't turn it over to their learning leaders because they're talking to the global CEO who knows enough to ask some very difficult questions about this. So now you've begun to get some gas going. You're starting to move things around. You're beginning to cook. You need to then look, how are we doing? So one of the things we built actually years ago with the Gates Foundation, and this is available, you can either come after me or you can find it on the Department of Education in the US in their EdTech Developers Guide. This tool is in there. It's a checklist for learning, and it's a simple top-level checklist, but every item in it has several different pieces that are grounded in learning science. So we applied it to 9 of our largest products across all of Kaplan, some test prep, some virtual university courses, some other things. And what you'll see here is, some of this, like personalization, as an engineering matter, it should not be perfect because it is so expensive to do personalization that it just doesn't make sense to have everybody investing all the money needed for personalization if you haven't done the other stuff. However, look at the objectives line. 3 of the products had terrible objectives. Well, there's just no excuse for that. I mean, you know how it comes about, What are you teaching? I'm teaching what I teach. Thank you for that. That's often what happens. So, I just teach what I teach. That ends up being, I don't know what I'm teaching. Nobody else does either, but I do what I teach, right? So, we can fix that. And the same thing with assessments. This was a few years ago. That's weak. Assessments are not that hard to get right. You just have to think about it. They're not a giant media burden. You just have to think about it and get it right and pay attention to it. So this showed us we got room to improve. We also, as I mentioned, began running randomized controlled trials out of Kaplan University. And by the time this was done, I think there was something like 100 randomized controlled trials we'd run. By now, we're up to like 130, 140 of these things. And what's great about an environment where you have lots of students cycling through and they're off sequence, like month by month, we'd bring on 1,000 students into the composition course or something, it means you can actually get a portfolio of work. And so this looks like a proper kind of engineering portfolio where most of the things are those gray bars that are inconclusive with no firm recommendation, which means we haven't got it to work yet, but we're not giving up. All of these things we test because there's evidence from somewhere, either a laboratory or another related learning environment, that this works. So none of these are, hey, look what I saw on the cover of Time magazine. I think I'll run a randomized controlled trial. None of these are like that. These are all things that ought to work. They have an active ingredient, apparently, and now we're trying to get it to work in our environment. So a lot of the time, it doesn't work. But the point is, if you're doing engineering, you don't hide. Because you're doing it because it worked somewhere, so you start to tinker. But that's where having a lot of these, rapid-fire pilots available to you means you can just start allocating pilots and tinker. So we did. So we also have a number of things that absolutely did turn into things. We roll it out. It's working. We roll it out as is. That's great. We also have some things where it didn't work, and we didn't use it, stopped it. Now, what's interesting is we're not a research organization. We're a learning engineering organization. So that a negative result, a solid negative result, is just as valuable as a solid positive result because you stop the pain, right? You don't keep doing a thing that isn't giving anybody any benefit. So it's very valuable to know, stop. We're not paying for that. We're not wasting their time doing that. So all of this kind of work really matters if you're going to really do learning engineering. You understand the outcomes you're after. You deeply go after those. You use evidence-based design methods for this. And then you've got good measures that you keep improving with data and evidence and psychometric methods. And then finally, where you have technology-delivered instruction that allows you to do some rapid cycle tests, you do them in the same way that other Silicon Valley companies do as well. So thank you very much for your time.